Hi, it's Mike. Welcome back to my shop. Haven't had a video for about a month. Sorry about that. My gallbladder decided it no longer liked me and left, kind of like Elvis, it left the building. But staples came out this week. Doctors released me. So back to full speed. Feel really good, actually. Probably better than before, so it must have been failing for a while. Anyway, I have done a little bit of stuff, light stuff that I could do, but I didn't really film any of it. I'll show some modifications I did to the lathe tool post to make it indexable, which I think a few people will find interesting, hopefully. And the other little project we're going to do today, just see if it'll work, I don't know if it will, is I've got, where did it go? And I'll bring it all in and show it. I got this SDJCR insert holder, and it uses these DCMT half-inch inscribed circle inserts. I mean, I bought these off eBay as surplus. It was cheap. I know why it was cheap. It's actually not cut far enough back for the insert to fit into. You can't get the screw in. So we're going to try to I tried filing it, and it's pretty hard, and the file just doesn't take enough off, and B, it's at an angle, and it's so short you can't get a very good stroke on the file, so it wasn't turning out well. So we're going to try to hold this in the mill and cut it, and let me move the camera, and I'll bring in on the sine plate and show you how we're going to do that. Okay, hopefully, I know it's still going to be hard to see. I could zoom way in, but then I have to go out again. Anyway, so this is the insert that it takes. And there's some file marks on here. I already played with it, so it doesn't look as pretty as it did. But anyway, slide the insert all the way in, and I know that's not going to show up probably on camera, but in any case, if the hole does not line up, the screw won't go in. If you hold it up, you can start the screw, and then, but if you push it back, the screw just won't seat because it just doesn't go back far enough. So I'm going to try to salvage this, even though it was only, I don't know, 25 bucks or something like that. It's still, I don't want to throw it away, and be a nice holder to have. And I got a couple boxes of these inserts. So what we're going to do, this is the tricky part on this. I don't know how it's tricky, but it's a compound angle. So these are 55-degree inserts, 55-degree included across the narrow part. And then it's a 3-degree offset in the tool holder. So the total angle of this right here is 58 degrees. So and then it's got a 7-degree rake on it, relief I should say. So that means that this angle here is 7 degrees, so the insert will seat up against it good. So we've got a compound angle. So what we're going to do is we're going to break out the ancient sine plate, and we're going to use the sine plate and a sine bar to get a compound angle. So we're going to put this in the mill vise and indicate it in. I got a little miniature magnetic sine bar, so we'll calculate the angle on here. Go this way, so that we have our 58 degrees, so we can indicate this, and it'll be square. I haven't looked up the chart on that yet. Is it still in the frame? Yeah, it's in the frame. So we've got this for one direction, and then we'll calculate the, and it's locked down now, but we'll calculate the amount of rise we need to get 7 degrees on this, so that we'll tip it like this, so that way our end mill will be at the right angle there and the right angle this way. At least that's the theory. An old retired toolmaker gave me this sine plate last year. I actually haven't used it until today. I haven't needed it. So I had to make up a couple really quick little clamps to be able to clamp this down. I didn't do that on camera because they're just 1x2 pieces of bar stock with some slots in them. Pretty boring. Anyway, so we got this little guy. It's actually pretty cool. He also gave me this, and I have used it before. It's a mini sine bar, and it's magnetic, which is really cool. It's got a V groove in it. I don't know how old this is. It's definitely not new. But what's kind of cool, so it's got this this little old, one of the old style boxes. I'll show you that. And on the inside, it's got a quality assurance certificate from Kingman White, Placentia, California. So I have no idea when this was made. It is most certainly not of modern manufacture, but it comes with, and it's kind of beat up, but it actually comes with the a little book that has all the sine tables in it. Of course, this was in the day before everybody had a calculator and little programs to figure this stuff out, or you had to look it up in Machinery's Handbook. So this actually comes with it, and then you can see in here, where does it? It might say it. It says it somewhere. I don't. It's somewhere. I saw it on here. In any case, so set it with adjustable parallels. Of course, you can use gauge blocks. But if you look, the rolls on here are different diameters. So this is actually a 100 thousandths, 200 thousandths smaller than the big one. So these actually have, here it is. It says like here. These values include the 0.1 dimension. So it actually gives you the stack height you need and accounts for the size of the smaller roll, which is pretty cool. So we're going to use this to get the big angle, and we'll use regular gauge blocks on the side plate to get the 7-degree angle. So let's see here, for 58 degrees, what do you know, I got lucky, it's on the back page because it's kind of falling apart. But 58 degrees, 0 minutes is 2.2201. So I need 2.2 inches to get our 58 degrees. So let me go grab the gauge blocks and see if we can do that. Okay, it occurred to me while I was grabbing all this stuff that I may need the same gauge blocks, well, not exactly the same ones, but for the 7 degrees. So for this 58 degrees, I'm going to use some big adjustable parallels. So we need 2.2201. So got our handy 2 to 3 mic and some adjustable parallels. I mean, the difference between 1 minute of arc on this is about 0.04, or 4/10. So if we can get within a half a thou, that's fine. It's not like this has to be super good. It has to be close, but not super good. So I'm just going to set this at 2.22 and a tenth, and lock the mic. And it'd be nice if I had a stand for this, but we don't, so that's all right. I'm gonna get this will get us pretty good. Okay, so that's up against the mic. We'll snug up the parallel here. And measure it and make sure that it held pretty good. I think it shows, I don't know. So that's 2.22, and that one's actually about 4/10 on that end. And on this end, whoops. On this end, we're at about 4/10. So it actually moved a little tiny bit when I tightened it up. So, but that's within 3/10. That's less than a minute of arc, and I'm just going to call it good right there. That's close enough for this. So we're going to use this. So we're going to take our. We're going to use this as our stack. I don't know if it's going to work. It might not. It might just be too big. Yeah, that's not going to work. Bleh. All right. Well, back to the gauge blocks. So, all right, so we need 2.2201. All right, So we have a 2-inch. We have a, whoops, 140. I grabbed the wrong one. I needed 120. All right, we got a, so we've got a 120. Man, I am just grabbing the wrong ones. 114. I meant to grab 10001. Okay, or 1001. All right, let's try this again. So we've got a 2-inch, a 0.120, and a 0.1001. So that'll add up to 2.2201, which is exactly where we wanted. So these should ring together. Oops, not quite. We have gunk on them. Let's try here again. Yeah, those ring together. Clean this off. All right, so there's our stack for this, which, well, still is big. That just does not seem right. It's not, because I did the math wrong. So we need 58 degrees. We need the other direction, so it's not 58. Oh, wait, hang on a second. Boy, that seems awful, awful bad there. What am I doing wrong? Hang on a second. Let's get the protractor. I'm doing something stupid here. So I did measure it. It is 58. Let's see here. We need... So, oh, yeah, well, we need 90 minus, we actually need 32 degrees, not 58. We need 90 minus 58. So we need 32. So let's look that up. And our little handy chart here. So we need 1.4248. So let's try that again. So anyway, we need 32 degrees, which I said was, let's see here. 32 is 1.4248. So we've got our 8/10. We've got our 24. And we've got our 2. So that makes 100. So this will give us our stack. So that's 220, 324, 424 is 8. So let's see, these all should ring together. And our 1-inch block. Come on. There we go. Whoops, I knocked 2 of them apart. All right, so there's our 4248, and I should go get a mic and check it, but I'm sure it's right. So now, when we put this on, we'll indicate on here. This will be at the right angle, and I think it'll show up. You can see that it is actually it is square, and this is square, so that'll work out pretty well. And actually, we could take this fence and just put that against it, and just push it up against it and clamp it down. We'll probably do that. That way, we don't even have to indicate it. And then I'll get the blocks. I'll calculate this one, and we'll do that. Anyway, let me move the camera, and we'll take this all over to the mill and see if we can make it work. Just as an aside, it is, I think it's March 15th, and it is stunningly nice outside today. It's about 75 degrees, which, you know, for 6,400 feet of altitude in Colorado is not the norm. But it is, you can see the sky, it is just blue. Basically only tiny light clouds, and it's just gorgeous today. So this is the view from my shop door. Okay, while we're here at the mill, I've got the sine plate clamped in the vise on a couple of parallels, so we can get to the clamp screws so we can adjust it. We've got the fence on the back side. We've got our stack in here to give us the 32 degrees we need, which is correct. There's actually an eccentric on this. I've tightened it down so it's all tight. So we can put that up against there. And then this is square here. Let me grab a solid square. Just as a sanity check. Just as kind of a sanity check. So that one's kind of big. Hang on, let me get a smaller one. Just to make certain that we're square here. And it looks really good. I believe we are. Yeah, it looks pretty good. Certainly good enough for this. Anyway, so that's going to be that. What we're going to do is clamp it down. I just made a couple of little strap clamps for this, and I've got some 5/8 by 3/4 cold roll to use as a block. Should probably go find a washer for this. Anyway, we'll put a couple of these on there and get it up against that. I could indicate it, but I'm just not going to worry about it. It's going to be plenty close enough for what we're doing. So we'll get this, and then the next thing is going to be to get a wrench. All right, so we'll just kind of hold this up against our stack real good, snug. Doesn't have to be super good. It has to be pretty tight. We'll just snug that down. Okay, so that won't go anywhere now. So then we got to get this over at 7 degrees. So this sine plate has 5-inch rolls. So there's obviously charts and all that, and just going to show a little. I don't know if I can do this and have it come out. Let me see. Anyway, I got a little. I have a spare phone that has no SIM card. I just keep it out here for shop use. It's basically a little mini computer. And I bought this little thing called Machinist Calculator, and let's see if it'll come up. It's not the greatest program, but I can tell you for some things it's really good. It's got a little sine bar utility, so you just tell it the length of the rolls. In this case, 5, and then you tell it the angle you want. In this case, we want 7 degrees, and you can go minutes, seconds, all that. And it'll come back and calculate all the other variables. What your angle is up here, what your stack height is. In this case, it is 0.6093. So anyway, that thing costs like $5, I think. This is an Android. I don't know if they have it for iOS devices. They might. They probably do. I'm sure there's something equivalent. There's other things that'll do it. Anyway, so we need 609 for this. So we've got a 400, a 0.1003, and a 0.109. So those two together will give us our 2093 plus the 400 gives us 6093, which is our 7 degree stack size. So we'll put that underneath our sine bar. So now we're at 7 degrees this way. We got our 32 degrees this way. Just hold it down. Snug it up. And I don't know how old this sine plate is, but it's it's cast iron. It's definitely not very new. Let's see, the heck brand was this thing? It is a Robbins Engineering Company, Detroit, Michigan, model B5, serial number 4677. So I don't know if the 46 is the year of manufacture. I don't know. It definitely has an old look about it, and it's got a few dings in it. Overall, looks pretty good. Certainly good enough for what we're going to do. So we'll snap this guy down, get another little clamp, put that. Yeah, it's not flat right there, so we don't want to do that. I think I'll just put it back here. This will give us pretty good, and we're going to get our little mini bar out of there. There's no reason to do that, and since it's magnetic, it attracts chips real well. So you know what? Let's see if we can't put this over here. That'll work. Give us a little more support close to the front. Yeah, it's kind of hokey. There's not another good spot. That might work. That'll work. We'll go with that. As long as we're not straddling the little line, it should be fine. All right, so that should give us sufficient clamping pressure. So now our mill axis will be on 7 degrees aligned with this, and this will be parallel to the Y. So I'm going to get a 1/8 solid carbide end mill, and we'll get it in there, and we should, with any luck, be able to pull this off. And I don't have a good number for how far the let's see here, hang on a moment. I don't have a good number of how far this needs to go. Looking at it by eye, I'm going to guess it looks like about 10 thousandths, maybe 15. It's really hard to say because it's just kind of sighting down through the hole, looking at the bolt threads. So it's going to be a kind of a trial and error. I'm just going to take a few thousandths and try it, and then we'll take a few more thousandths and try it, and see where we go. We better lower our table down a little bit though. And the tripod's in the way. Well, I gotta move the camera. Okay, I think we're ready to go. I got you zoomed in pretty tight. Hopefully this will all show up. Here's our insert. So we can test. I actually ended up moving this clamp back slightly because it was overlapping where I couldn't put the insert in. We got it dropped down far enough where we can get this in so we can try it. Oh, you know what? I gotta speed the mill up. So let me switch the belt real quick because it's on slow. This is solid carbide. I don't know exactly how hard this is, but yeah, we'll move it. It's a step pulley mill, so it's kind of a pain, but really it's not bad. It takes 30 seconds to move the belt, so that's cool. That'll give us 1700 or 3400 RPM. So I don't think it's that hard from when I was trying to file it, but we're going to start slow. So let's see here. Does this look square for a sanity check? And it does. The angle looks good. So what I'm going to do is just, so we don't want to go any deeper. So I'm going to go in here and just touch the spindle, zero our quill DRO, and then I'm going to come up about 1,000th. And it was way more than 1,000th. There's 5/10. So I'm just gonna, just as a sanity check on our angle, I move it across. Actually, that's not gonna work because this is at an angle to this is not. So we can't do it that way. What we're gonna have to do, come up over here and touch off right in the corner and just lock the quill. Maybe just barely touch it and lock the quill. Okay, so here we go. Let's see what happens. Oh, turn my safety box back on. It's 1700 RPM. Not very fast for a small carbide mill, but yeah, so it's got a relief in the back. We're not going to go further than that. I'm going to take 3/1000ths to start with. This is definitely cutting. So we definitely made a cut. Let's see if can't really see the screw hole, so I guess the only way to really know is we'll just try it and see if our screw goes down all the way. Look at there. Just, it's a little tiny bit off, it looks like. I'm gonna say I don't want to go too much. I definitely want it to fit good. I'm just going to take 1/1000, lock the table, and we'll see what that does. Come down real careful on our depth here and just touch. Hopefully you can still see this. We just touched. Okay, we're into our relief on the back. All right, let's see how it fits now. Looks good. That doesn't mean much. Like I said, can't really see the hole, so all we can do is see if our screw goes in all the way without any binding this time. And could still go maybe a little bit more. I can see a gap at the front of the screw, so I think I'm going to go 2 more this time. I think we're really close though. We don't want to go very much. So my 10 or 15 thousandths was going to be a way overestimated. So let's, we're going to go in, whoops, too far. Okay, that's, table moved, hang on a second. Okay, we're at 6 thousandths total that we've come in so far. So let's bring it in, and then we're gonna touch the bottom again. I think we're good there. You can see those shavings are really small because we're only taking about 1.5, 2 thousandths off. Okay. But it is cutting real easy, so this can't be real hard steel. I mean, it's solid carbide, but it isn't even putting up a fight. So, see how this fits now. It's looking pretty good. It's looking pretty good. It snugs down, and you know, I still have a visible little gap up at the front and nothing in the back. So I'm going to take, I don't know, 2 more, I think. And I just, you know, it's a one-shot deal. We definitely do not want to go too far, because that, and it's a throwaway, which, you know, I'm just trying to prevent it from being a throwaway as it is. So let's go over 2 thousandths more. Whoops. Table moved a little. According to the DRO, there we go. So now we're at a total of 8 thousandths. And let's come over here. Just gonna touch down for our Z. And the mill was, the cutter was in a spot where I could bring it down without it touching in between the flutes. That's why I was able to do it that time. Okay, there's our 2000s. Depth looks pretty good. Make sure we got all the way to the back here. Cleared our slot. We do. All right. I think we're gonna. That's probably gonna do it. I don't want to tempt fate and try to go too far. I don't want Mr. Bozo to visit from California. He needs to stay over there. So let's see how we do here. Yeah, oh yeah, that's a lot better. I think we're good. I'm gonna call it. So let me see if that still shows up in frame. It does. Just take it out a little bit. I'll take this out of our setup here. And you can see it sits up against in there now. And it looks like the gap all the way around the screw head is even. The bolt fits down in there without any problem. The insert actually locks in really tight. We'll put it on the lathe and make sure it works right, but I think this one's going to be job done. I think that's going to be it. And we'll just really quick set it up on the lathe and test it out. Let me get the camera turned around.